In this 3D printing mastery, we're talking about infill and how you can use it to make your 3D prints stronger, lighter, or prettier. Filament 3D printers have a unique ability. The models they produce don't have to be solid. Instead, they can be printed with a sparse lattice structure inside, which saves a considerable amount of material and time. And you can adjust these settings to ensure that the final 3D print looks good and is strong enough for its intended purpose. This is a pretty incredible capability, and this internal structure is known as infill. With modern 3D printing slicers, like with Orca Slicer here, there are many different infill types to choose from, and they all have their own advantages and disadvantages. But it's really important to note that these infill structures are not part of the original 3D model. You don't have to design them in. Instead, the slicer generates infill all on its own, and the settings are infinitely tweakable. When it comes to changing your infill settings, you can choose from the kind of infill called the sparse infill pattern and the density of that infill, from grid to cubic to gyroid and many more. There are a ton of different patterns to choose from, and the density of all of these can be adjusted from almost completely solid to a medium density to sparse and then, well, completely hollow with no infill at all. The default infill settings for most print profiles are a good balance between strength, print time, and material use, but every 3D print is different. So let's consider a few reasons why you might want to change your infill settings. Let's start with print strength. Let's say you want a part that's really strong. Well, in that case, it's a good idea to have a reasonably high infill density. But that's only part of the story, because some infills are better than others when it comes to part strength. For strong practical prints, I like to use cubic, which is a fully three-dimensional infill type. This helps to give the part a uniform strength, and it's quite different in its behavior compared to rectilinear infill, which is only strong in one direction. There are other important settings to tweak for ultra strong parts, but that'll be its own video in this series. Make sure you subscribe so you don't miss it. But let's be real, not all prints need to be strong, and that high infill uses up an awful lot of material. So what if you want to print something really large, but purely decorative instead? Well, in that case, a sparse cubic infill will certainly save you some time and material, but there are other infill types specifically designed for prints like this. Take support cubic. This is a variation on the standard cubic, which changes the internal density intelligently depending on how much internal support the print actually needs to complete. And then there's lightning infill, which takes this idea to the extreme and creates single extrusion platforms which fan out to support the layers as they're printed. This infill type does nothing for the part strength, but if that's not important, it'll save you a ton of time and material. And if you really want to push this idea to the extreme, then maybe consider printing with no infill at all. A word of warning here, not all 3D prints can be printed with no infill because some prints need the internal structure to be formed correctly. But as you become comfortable with understanding the print preview, like I discussed in the Orca Slicer video in this series, you'll start to identify models that can actually print with no internal infill at all, that is completely hollow. And if you get away with it, it's a really clever way of cutting down print time and material use dramatically. And then there's the odd infills, like gyroid. Gyroid is this funky three-dimensional alien-looking surface that was discovered by a NASA scientist in the 70s, and in recent years it's been adapted into a 3D printing infill. Do I fully understand how or why it was created? No, but what's really cool about it is the fact it doesn't create any isolated pockets inside the print. It's all fully connected. This means that it works great for squishy prints where you want them to deform uniformly before springing back. Just be careful with gyroid because the rapid wavy movements it needs can really shake up a 3D printer. In fact, with many modern 3D printers, I've discovered that they print gyroid rather slowly, probably to avoid this issue, and other infills like cubic print a heck of a lot faster. And finally, there's the really weird infills. Infills like Hilbert curve or Archimedean chords. These can be fun aesthetic choices, especially if you disable the top layer of your 3D print so the infill is always showing through. but I'll be honest, I've almost never used them. They're fun to play with, but maybe not the most practical infill patterns. For this video, I've put together a cheat sheet on my top choices of infill pattern and recommended infill density for a range of different printing projects, and I've bundled it with this sample project that shows how all of these different infills look within Orca Slicer. You can find it linked below along with a link to our Patreon, which you should definitely consider joining because the 3D Printing Mastery series wouldn't be possible without the support of my Patreons, and they get to shape the direction of this series with their questions and discussions in the linked Discord server. In the next 3D Printing Mastery, we'll be covering the many different kinds of filament you can print with, from the old and dependable to exciting new materials you just have to try. So if you want to expand your horizons beyond PLA+, be sure to subscribe.